Okay, so I'm Elisa. I work in the network automation space for various companies. And we've been working together with a friend of mine, David Barroso, who is at Spotify. We've been working on a project to automatically deploy router configurations in a multi-vendor network. We came together because we both had the same need of configuring our devices, and we had similar devices on our networks. So we joined our forces, and I'm gonna talk about the project, which in the end is a Python library that you guys can use as well, and explain it. And half of this is going to be a little bit about the library, and the second half is going to be a demo to see how this works. So we called it N.A.P.A.L.M, short for Network Automation and Programmability Abstraction Layer with multi-vendor support. Yes, it's open source. You can find it on GitHub. The URLs are on the last slide of the presentation. And what it gives you a unified API that you can talk through multi-vendor devices. So you can specify, I'm uploading a configuration to a Juniper router and it will do whatever it needs to do for Juniper, or upload configuration to a Cisco and it will do whatever it needs to do to talk to that Cisco. You can manipulate the configs. In a newer version, we also built in functions to retrieve data. The vendors that we supported were the vendors that the two of us, between me and David, were using at this time. So feel free to contribute if you need any other vendors at this point. We had Aristas and Junipers in the network, and then Cisco iOS XR, and David had some FortiGate firewalls for whatever reason. So the first thing we did was, so we would be able to deal with the configurations, was to implement a bunch of functions that do config manipulation in a similar way as you would typically expect it on a Juniper, or any other router really. You can replace the config, you can merge the config, you can show diffs, you can commit or discard it. Some of the vendors didn't quite have the concept of loading a config and then later on committing it, like Arista's EOS. So we built that into the library that abstracts it from the hardware really, so that all the functions for all the vendors that this supports are identical to the way you're using them. They will produce the same result for the user at this point. In a second version, we built in a couple of get commands to retrieve data. It will all come out as structured data in the same structure that we've defined. So we took great care of making sure that every structure is going to look exactly the same for each vendor, and you know what to expect. So then, because we wanted to manage our network out of Ansible, we wrote Ansible modules that come with this package that you can use in your regular Ansible playbooks. Now, the demo is going to be a little bit about Ansible and a little bit about N.A.P.A.L.M. Let's see, who has used Ansible before? Okay, some. Okay, let's see. If you have questions in between, stop me, and I hope this is going to work. We did this presentation before at NANOC in San Francisco a couple of months ago, and at that time we had a great lab set up at Spotify in David's lab. I don't have access to that lab right now, so unfortunately this demo is a little smaller than the previous one. If you want to see the previous one, check out the video on YouTube. And this one I put together on VMs on this laptop yesterday night. So let's see how this is going to go. Okay, so we have 3 routers configured initially just to see how this is working. To be able to reach the box via any mechanism, you'll need to have some basic connectivity configured on it. So we have 3 VMs set up with management interface and IP addresses on them. Okay, let's dive into the Ansible part of things. So Ansible divides up files in a very particular directory structure. So the first thing that really struck me about Ansible when I started using it was the way you kind of define your directories. It defines where you put all your hosts that are part of your network. It defines where you put all your variables, and then it defines something called tasks or playbooks that are kind of like scripts you run, and then command by command, like a shell script, they will execute each statement. So this is how an inventory file looks like. The 3 devices we have. Do I see my, no, can't point. So this is our iOS XR core device and 2 Juniper Edge devices. In the inventory file, you can group things together depending on if you give it a different role or if you want to configure different services on it. You can batch things into those groups, and then later on when you run any command in Ansible against those devices, you can use the group names and divide up your configurations based on what part of your network those devices are in. So then the first step that we're going to do with Ansible is take templates and variable files. The templates are going to be replaced. For each vendor, you have to write a separate template pretty much with whatever vendor's syntax for the configuration it has. And it's going to use the variable files to replace whatever is in your template. So for example, we have a variable file that applies to the entire network, and the entire network has the same user configured, the same password, configuring a directory in which the generated template file and the generated config files are going to be dropped in after the templating is done. And then I'm defining a couple of variables for my routers, DNS servers, NTP servers, etc. And then in addition to the global file, we can have per router files. And this is a great example of how you want to abstract your data. So you want to abstract the actual data that goes into your router from the configuration. So the data definition in any case is going to be exactly the same. It's all going to be variables placed in files like this, and then the only thing that differs per vendor are the templates in which this is replaced. So in addition to the global variable file, we can have, for each host, we can have an additional file. I'm defining the host name, the management IP, and I'm giving it a couple of interfaces and IP addresses to those interfaces. We will configure all of that in a minute, so we'll get there. And this is the same file for a Juniper, so you can see it has the same variables. It has a host name, a management IP. It has a list of interfaces that are configured. What you can do funny things like, so in the global file, we had a username, but then on the iOS XR, I configured a different username so I can overwrite that variable in the particular host file, so it won't take the global one, but for the iOS XR hosts, it will take this. Okay, template files look like this, just to give you an idea how all of this looks like. In your iOS XR syntax, host name, and then it will replace this host name from the variable files. The syntax to configure my management interface, the syntax to turn on SSH and turn on the XML agent. Similar for Juniper, I'm doing host names, and I set the password, and here I have my interface, my management interface with the IP address. So I prepared those routers in this way. What we're going to do is we're going to add a couple of more interfaces, the ones you saw in the variable files, here and down there, and on the iOS XR over there, just to configure a little bit something more than we have going on those routers right now. And this is how we're going to start all of those things. So I'm gonna do those things on my VMs in a minute here. We're gonna split this up into four different steps. So the first one is just bootstrap the system with the management IP addresses. The VMs that I have already are prepared this way, so when we run the first commands, nothing should change on the routers. We'll see if that's actually the case. Then we're gonna add some system configuration. Those were the DNS servers and NTP servers. Then we're gonna add some interface configuration. And then we're going to enable OSPF to see if everything kind of worked out and to have something to look at. Now, let's see if this is going to work. Okay, let's start with the first. Actually, let's look at the routers first, just so you have an idea. So this is my Ansible directory here, and this is where I have all of the files that we just looked at. So this is my this is my host file here. This is my let's see, what else can we look through that is interesting. This is the base config template for Junipers. This is what we saw on the screen a couple of slides ago. So this is my prepared routers with only the management IP configured on them and nothing really more. This is one Juniper. This is the other Juniper. I'm gonna stick to those two because my laptop seems to be crashing the iOS XR VM, so we're gonna leave it at those two for now. Okay, so here's what we're gonna do. We're gonna run the first command. The different steps are split up into, the first command is generating the configurations, so we can look at the files in between, see what it did, and then the second command is the one that actually commits it to the routers. So when we run this, first of all, it checked if the config directory was already there. Then in a second step, if it was there, it deleted it, so we don't have anything old in our directories anymore. In a second step, it generated the candidate config, and then in a third step, generated the directory, and then in the third step, it replaced the template. So theoretically, we should now, in our config directory for, let's say, the first Junos router, have the same configuration that we already have on the device right now. This should not differ at all. Now, since we already have it on the device, we might as well deploy it, and nothing really should happen here. So now it takes that the configuration and just pushes it out to the network, and it says everything was fine. You might have noticed before it said that something had changed, which means that it actually performed something at this point. And here the commit on the Juniper actually figured out that the same configuration was already loaded to the Juniper. So okay, in this case, just means I haven't done anything because everything was already in this state. Now, let's add some NTP and DNS servers just to have something going on. So I run the command to generate the configuration, and then if we look at the config, it spit out a little bit of system config. This is what I would want to have on my Juniper to put on a name server, put on an NTP server, enable LLDP. Now, if I take this and push it out to the router, at the same time, N.A.P.A.L.M also puts a diff file into the config directory. So once I push this out, I can see what it actually changed. So this is what it actually deployed to the router. And if we now look at the router, there's a new pieces of configuration of just system important stuff. Okay. Next step, we have a couple of interfaces. So let's look at those interfaces and generate the configuration for those interfaces. What we configured, what we generated, let's start with that. What we generated looks like this. The interesting part about this interface config is really so this is how our variables look like for this. In the variable file, we pretty much give it a list of interfaces, and then the template that goes along to configure those interfaces. The template looks like this. So Ansible templating is a little fancy in a way that you can have for loops in it, so you pretty much define your configuration for your interface once, and you can just tell it for all of those interfaces that I have in my config file, run through in a loop and configure the same thing every time and every time. So based on the variable file and this template, we created this configuration. So now we use N.A.P.A.L.M in the second Ansible command to deploy this config. Okay, now it actually says, and it already did that with the system part earlier, that it actually changed something because this configuration has not been on the routers before. So let's look at what we actually have now here. We have NTP servers, and there, in addition to the first management IP address we had, we now have the other two interfaces that we had specified in the variable file configured. It does, I'm showing this on one router, it does the same thing on the other router. So the other set, it has the corresponding IP addresses there. Okay. So now for the fun of it, let's turn on OSPF. Let's see, how did OSPF look like? So for OSPF, template, the OSPF template for Junos looks like this. I'm creating one area and I'm placing all of the interfaces that I configured previously in that area. For iOS XR, the template would look like that. And it would again go through all the interfaces that we had in our variable list and configure that. Then the variables, we've seen this before. I'm just going to pull it up one more time for it to be host Juniper. So again, the same interfaces, everything taken out of this one configuration file. So if we generate this, we now have OSPN configs lying around in our config directory. They look like this. And now if we deploy this, let's check out the diff that we have. If we deploy this, this is what it actually uploaded to the router. Now let's see if it did that. It looks like it did that. This is gonna take a moment here, but this should all establish in a second there. Okay, so what we did is, let's recap this for a minute here. So we bootstrapped the system, that was already the same as before. Then we added some system configurations. Then we added interface configs, and then we added OSPF configs. Here we go. So now we actually see that something shows up in our OSPF database. Okay. So what did we do? We had our devices broken down into different functions or different services. Just for demo purposes, I broke it down into system, interface, and OSPF. But in the end, if you want to look at the demo we did at NANOG in San Francisco, there was way more complicated services that went across an entire data center network that you can split things up into. It's a matter of structuring your data and structuring your config and decoupling the vendor-agnostic data part from the actual vendor configurations. So, if you want to do things like, actually, we have 10 more minutes, right? Okay, let's do something funny. So if we would now go ahead and want to install a different group variables, all. If we would now want to change our DNS server to something completely different, we would do this. We would run the systems commands again, the ones that deploy the the system NTP servers and DNS servers. Here we go. So let's regenerate that configuration. If we look at the config now, here is the new name server that we changed. And now if we deploy this, all of our routers in this example here have the new name server now in there. So what that gives you is that with a single configuration file, you're going to steer your configurations and not have to, imagine you have 50 routers and you're trying to change your DNS servers on all of them. So you change it in one file, and everything is going to be deployed on your network through the system. That's to summarize the key benefit pretty much of decoupling your data input and your templates for your network. Okay, so we could technically run the combination of those services would build the full configuration. So we could technically run, I split this up into different steps here for demonstration purposes. We could run all of this in one command, and it would generate the entire configuration, upload this to the routers. So if we have our configuration saved offline in this manner, if we ever need to replace a router completely, we bootstrap it with a management IP address, and then we just configure everything through the system. So in a sense, we have a backup of we have offline generated configurations that are going to make our lives so much easier if we ever have a router fail somewhere. So we push the configuration, the delta is applied because it uses the Juniper or iOS XR commits that know if a portion is already configured, so they only apply the delta that we push to it. And the playbooks and the data files are all completely vendor agnostic, so we can write them the same style for our entire network, no matter what vendor we have. Many vendors actually provide this type of Ansible or Chef playbooks. So the real benefit of N.A.P.A.L.M and why we needed N.A.P.A.L M at those particular networks was to have the vendor agnostic option. I could always use the Juniper Ansible module to only push data out to a Juniper, but that would not allow for me to do this in a multi-vendor environment out of the same system. Okay. So I put a lot of URLs in here, just if you guys want to check it out. So N.A.P.A.L M is on open source and on GitHub. You can find it here. I put all the files that I used in this demo on GitHub too, so if you want to check them out, they're on there. We have a mailing list for some people are using this for their networks, so if you have any questions or any problems, if you want to try it out, email us. And here's a video and the demo files for the NANOC presentation that I've referenced a couple of times, because the setup was much more elaborate than what I've showed you guys today. So if you want to check out a little bit more complicated setup, go there. All right, any questions?